Alrighty, so now that we've had a brief introduction into inequalities, we're going to dive in deeper with how do we solve one-step inequalities. What you'll notice in this video is that you'll find that solving one-step inequalities is very, very similar to the process in which we solve one-step equations. We do have a vocabulary term. An inequality is simply a mathematical sentence that shows the relationship between two quantities that are not equivalent. And if we remember, an equation states that two quantities are equivalent. That's the biggest difference with an inequality and an equation. So we're going to start with adding and subtracting with one-step inequalities. So here we have x plus 5, here's our sign, less than. So x plus 5 is less than 12. The way we solve this, just like with equations, we need to use inverse operations to isolate or get our variable by itself. So on the left side of my inequality, I need to get rid of plus 5, and to do that, I need to minus 5. So I've minus 5 from the left side, and I just have my x. I'm going to bring down my inequality sign. Trying to make that look like an inequality sign. And now I need to minus 5 on the right side because that is the operation that I did on the left. So my inequality now, well, 12 minus 5 is 7. So my inequality is x is less than 7. So now, to bring in something new, we need to graph the solution. So if we remember from our flip book, the first thing we need to do is create that number line. Seven, 8, 9, 10. We'll do 6, 5, 4. So I'm going to plot my point at 7. There's my circle. It is not equal to 7, therefore my circle needs to be left empty. And now I need to determine the solutions that would be less than 7. So that means my line is going to go towards the left. So this is showing that the solutions to this inequality are numbers that fall to the left of 7. So if I picked a number, let's say 4, and I put 4 in place of x, I would say 4 less than 7. And when I read that, is that statement true? And yes, in fact, it is. We know that 4 is less than 7. Now we have another example. So the next example we have is 8 is less than or equal to y minus 3. So once again, thinking about this as if it were an equation, my whole goal is to get the variable by itself. So right now I'm taking 3 and I'm subtracting it from y. So I have to get rid of subtracting 3. To get rid of subtracting 3, the inverse of that is to add 3. So I now just have y. Bring down my inequality sign. And then I need to add 3 on the left side. So now I have 11. So my inequality states 11 is less than or equal to y. So on my number line, I'm going to pick 11 right there, 12, 13, 10, 9, and 8. That seems to be sufficient enough. Now, put my circle on my number, 11, and because the inequality is less than or equal to, I need to shade in my circle. So now I need to find out which solutions would make my statement true. 11 is less than or equal to y. So which direction would make my point 11 be less than? That would be going to the right. And to check it, if I pick this point 13 and I substituted it in place of my variable, is my statement true? 11 is less than or equal to 13. This is a true statement. Now what I'd like you to do is try these two on your own. I want you to solve the inequality, but then I want to see you graph it as well. Remember, you can always refer to your flipbook. So why don't you pause the video and then go ahead and solve these, and then we can check back and see how we've done. So my inequality states y minus 5 is greater than or equal to negative 7. My first step is to get rid of the number with my variable, so I have just my variable. So I'm going to add 5 because that's the inverse of subtracting 5. So I just have my variable y is greater than or equal to, and now I need to add 5 on this side. And now I have negative 2. Y is greater than or equal to negative 2. On my number line, negative 2, negative 1, 0, negative 3, negative 4. Notice how it's kind of hard for me to write with the stylus pen. Kind of looking like first grader handwriting here, guys. So my inequality is greater than or equal to. So on my point negative 2, my circle needs to be shaded to show that it is equal to. And now I need to check for solutions that are going to make this true. So y is greater than or equal to negative 2. Is negative 1 greater than negative 2, or is negative 3 greater than negative 2? Negative 1 is greater than negative 2, so my line needs to go to the right. And I could check this by any additional numbers to the right of negative 2. So for instance, if I pick 2, I can substitute 2 for y. And I have 2 is greater than or equal to negative 2. And I know that that is true because any positive number is greater than a negative number. Next one, we have 21 is greater than 12 plus x. I want x by itself, so I need to get rid of 12. I do that by subtracting 12. So I subtract 12 from both sides. So I bring down my variable. 21 minus 12 is 9. My inequality states 9 is greater than x. Plot the points or the numbers on your number line. Now, my circle at 9 needs to be left open because it is simply stating that 9 is greater than x. So which direction on my number line would make 9 greater than any of the solutions? That would be going to the left. So if I were to pick a point, once again, just like before with all these, we still have the same procedural steps. I'm picking a point and I'm going to substitute it for x, so I'm going to pick 6. So I'm going to have 9 is greater than 6. And 9 is, in fact, greater than 6. Therefore, we have a true statement and a true inequality. All right, moving on to the next page. We now have more operations. We just covered addition and subtraction, which are just like solving one-step equations with addition and subtraction. Now we're going to see just how similar multiplication and division with one-step inequalities is with one-step equations. We're going to see how similar these are. Let me zoom in here. Okay. So, my example, y divided by 3 is greater than or equal to 5. My first step, just like always, is to isolate my variable. So I need to get rid of the number with my variable, which is 3. I'm dividing by 3. Well, I know that the inverse of dividing by 3 is to multiply by 3. So I need to multiply by 3 on the left side. And I have y left. Bring down my inequality sign. I need to multiply by 3 on the right. And my new inequality is y is greater than or equal to 15. On my number line, I'll put 15 right here. Whoops. That was a very bad 14, you guys. Very bad. All right. So I need to plot my point at 15. And because my inequality is greater than or equal to, my circle needs to be filled in to state that 15 could be a solution. So now, which direction would make this statement true? Saying that y is greater than 15. So which direction are the numbers that are greater than 15? To the right. So I'm going to check it. I'm going to pick 17 and see if that is a solution that is true. And when I read it, I have 17 is greater than or equal to 15. And that is true. Here we have another one, a second example. Negative 4x is greater than 52. Now we do things a little different, and we've talked about this with the flip book briefly. When we have to multiply or divide with a negative number, something has to happen with our inequality sign to maintain a true inequality statement. So, to start with, I want to get my variable by itself, so I need to get rid of the number. Well, that's a negative 4, so I have to divide by a negative 4. And when I divide by a negative number, my inequality sign flips or changes. It's in reverse. So right now my inequality states that it is greater than. I need to change that to less than, and I need to divide 52 by negative 4. 52 divided by a negative 4. 52 divided by 4 is 13. And a positive divided by a negative is a negative. Now, when you come into class tomorrow, we are going to talk about why this inequality sign has to change. We're going to get down to the specifics about if it didn't change, how would the inequality sign be false? So keep that in mind when we come into class tomorrow. So my inequality states that x is less than negative 13. So on my number line, I'm plotting my points, and I know because this is a negative, negative 14 actually goes this way. And then I have negative 12, oops, negative 11, negative 10. There we go. Very sloppy handwriting with this stylus pen. So I'm going to plot my point at negative 13 because it is stating that it is not equal to, I don't need to shade, and which direction on my number line would be solutions that are less than negative 13. So ask yourself, is negative 14 less than negative 13, or is negative 12 less than negative 13? And I know that the greater the number when we're dealing with negatives, the smaller they are. So everything to the right, or excuse me, everything to the left is a solution. And I'm going to check that by using negative 15. And I'm going to substitute that for x. So negative 15 less than negative 13. And I know that that is true because negative 15 is less than negative 13. Alrighty, whoops, too much. What I would like to see you do is simply try these your turns on your own. There are 4 of them. Remember, what do we need to do if you have any questions on any of these 4 problems for you to try? Either write them down or simply email me, and we can talk about them in class tomorrow.